Hi, I'm blurry. It's time to start talking about onto and one-to-one functions. It's already confusing in itself, but it's even worse by the fact that you have not done anything related to this whatsoever before suddenly having to do this. All right, so here's our first example. First, we need to figure out if this is a function, and then if it is, we have to figure out if it's one-to-one, onto, both, or neither. Well, first we need to figure out if this is a function. What even is that? Well, the way I want you to think about functions is it is basically a machine, a food making machine. Now, I used this food making machine example in my last video, which was about domain and range. And if you haven't watched that and you're curious about domain and range, then the card on the screen, you might want to watch that. So whatever we put into the machine is going to be our input. And that is also known as X in math. And what you get out of the machine is our output. I know, shocking. And in math, that would be called a Y. So we put something into the machine, like, for example, a potato. Please don't judge my drawing of a potato. Actually, judge it all you want. I don't care. And now, let's say that this potato, when we put it into the magic food machine, I just realized this machine doesn't have a name. So when we put a potato into this magic food machine, we get fries. So whenever we put potatoes into the machine, it's expected that we will get fries out. So what would make this not a function? Well, let's say that when we put a potato in, sometimes we get out fries and sometimes we get mac and cheese. First of all, that makes no sense. I don't know why you would get mac and cheese from a potato. Second of all, this is not a function because for a function to be a function, whenever you put in an item, you need to get the same thing out every time. So in this case, let's ask ourselves, is this a function? Well, remember the ones on the left are x and the ones on the right are y. So whenever we put in -1 into our magic number machine, which is not as exciting as the magic food machine, but still sort of exciting, we get -2. When we put in 3, we get 0 every time. When we put in 3, we get 0. And when we put in 6, we also get 0. To me, that sounds like a function, right? You can get two things that give you the same thing. So, like, for example, if there was something else we could put into this machine to get us fries, that would be fine because we know that when we put that item into the machine, we're going to get fries. So, in this case, this would be a function. But now we need to ask ourselves, is it one-to-one and is it onto? What do those mean? Well, let's say that there was something else that we could put in to get fries. Let's say if we put in bread, then we would also get fries. In this case, this would be a function because if we put in potatoes or bread, we can expect to get fries out. But this would not be one-to-one because there are multiple things we can put in to get the same thing. For this to be one-to-one, fries need to be exclusive to one certain item. So there can only be potatoes that make fries, and there can be nothing else that make fries. So is this one here one-to-one? Well, no, because 0 is a thing that the machine can make, but 3 and 6 can both make it. So in this case, this is not one-to-one. But what about onto? Well, onto is a weird one because like 95% of the time it is going to be onto because it seems really weird. But basically, onto means the big list, as you could say, the menu of things that can come out of the machine need to actually be possible to get out of the machine. What? Well, basically, let's say that this machine said that it makes fries, ketchup, and chocolate. If the machine says it makes these three things, it should be possible to put something in and get each of these items. So, like, for example, we could put a tomato in and get ketchup, or we could put, what would we put in for chocolate? Like cocoa beans and get chocolate. You can tell I've played Minecraft. So what about this? Is this onto? Well, this is one of those rare cases where it's actually not onto. You see how it's promising that 4 is one of the y values here, but there's no way to make 4. There's nothing you can put in to get 4. 4 is just sitting here all lonely and you will never make 4. So in this case, onto is, this is not onto. All right, what about this one? First of all, we need to decide if this is a function. Remember, every item has to make one item. You can't put in something and then have maybe it makes this thing, maybe it makes another thing. It needs to make only one thing. So let's see, -3 makes 2, 1 makes 4, 2 makes -2, and 5 makes 4. There isn't any x value that can make two different things. So in this case, yes, this is a function. But what about one-to-one? Remember, for it to be one-to-one, each of these things that the machine can make needs to be exclusive to one thing that you put in. So in this case, it looks like 2 can only be made by -3, so that's good. But look at this. 4 can be made by either putting in 1 or by putting in 5. So you can put in 1 or 5 to get the same thing. In that case, 4 is not an exclusive item. So 1 to 1, nope. But what about onto? Remember I said onto is that one that's going to be true like 99% of the time. And in this case, it is, because it basically just means everything that's on the menu, or however you want to say it, is possible to make. And yeah, it's possible to make all of these by putting the thing that's next to it in. This is why onto is one of those things that's almost always true, but it wasn't in that last case. So in this case, we do have a function and it is onto, but it is not one-to-one. Okay, here's another example, and it's a weird one. We've got a graph, but you would do it the same way. Go ahead and pause the video if you'd like, try to solve it for yourself, and then unpause and see how you did. All right, so the first question is this a function? Remember, for it to be a function, you need to only get one thing out of each number that you put in. But where are the numbers that we're putting in? Well, remember, x is the things you put in, and y is what you get out. For a graph, x is the numbers from left to right, and y is the numbers from top to bottom. And immediately, without doing any sort of like complex math or anything, I'm noticing that here we have x equals -1, because you have to go to the left one to get to it. And there are 2 dots here. There are 2 dots for on -1, which means that if you put in -1, you can get 2 different things. That automatically breaks the rules of a function, which means that it is not a function. And we don't even have to answer the other ones like one-to-one or onto. We're just done because it can't be one-to-one or onto if it's not a function. All right, everyone, don't panic. The graph background is gone, but we still have graph points here, so enjoy those. Go ahead and pause the video, try this out for yourself, and then unpause and see if you got it right. All right, so first question, is this a function? For it to be a function, we have to make sure that we don't have a number we're putting in giving us 2 or more things. So let's see, -3 gives us 1, -2 gives us 2, 1 gives us -4, and 5 gives us 6. Yeah, I don't see the same input giving us 2 outputs. I mean, each one of these is different. So yeah, that's a function. Is it one-to-one? Remember, for it to be one-to-one, each of these items here on the right, this is our output, needs to be exclusive to one item. We can't have multiple ways to get the same number. Well, it looks like we have a unique number for each of these, and each of these only has one way to get it. So in this case, yes, this is one-to-one. And now is it onto? Basically, everything that is promised to be able to make is actually possible to make. Yeah, seems true to me. We have 4 of these numbers here that we can make, and we have a way to make them. So yes. So yes, this is a function, and it is both one-to-one and onto. So this is one of those weird concepts where, yeah, it's math because you've got numbers and stuff, but the best way to think about it is to just ignore the numbers entirely. I hope that really dumb food example has helped you realize that not thinking of these as numbers and more of just things that you can put into a machine and getting out something different helped you a little bit to understand this. But if you're struggling with onto and one-to-one, you probably also need to know about domain and range, which is one of the most commonly requested topics that people need help with all the time. In that case, then you can watch this video right here. And as always, if you have any questions, just leave it in the comments and I'll be happy to answer it. Thanks for watching. I want french fries now.